Okay, so next problem we're going to take a look at. This one is not actually a multi-part problem, so this one's just going to be, I'm not going to say straightforward because some of these are a little bit trickier. This one starts off with a weird note. It says, note, take east as the positive direction. And they say a, or an, in this case it actually is an 82 kilogram fisherman jumps from a dock into a 124 kilogram rowboat at rest on the west side of the dock. If the velocity of the fisherman is 3.4 meters per second to the west as he leaves the dock, what is the final velocity of the fisherman and the boat? So, the way we've got this set up, let's imagine that we've got water, and we've got a dock, and we've got a boat. Brown on here. I guess I could have planned this out better. Beige! Beige it is. Here's our boat. Now, I'm going to point out that this way is east. That makes this way west. I guess at that point, north is into the board and south is back towards you all. Okay, we've got the fisherman. And the fisherman is going to jump off of the dock into the boat. They're saying, basically, we're going to treat it as though the fisherman only has velocity in the x direction. We're going to ignore what's going on in the y, which is fine. Just like we looked at with projectile motion, what happens in the x is pretty much independent of what happens in the y. So there is some stuff that happens in the y. They go up and then come down. The boat might sink down a little bit, but that's not actually going to result in the boat moving side to side. What will result in the boat moving side to side is the horizontal velocity of the fisherman. What we've got is we start off with two objects, the fisherman and the boat, and we end with the fisherman inside the boat. This is actually an example of a perfectly inelastic collision because hopefully the fisherman's going to stay in the boat and then they are both going to move over. So what we're going to do is we're going to define a system of the fisherman and the boat. And what we're looking at is basically the fisherman as he's moving to the left, the way that I've drawn it, in the west direction. After he's left the dock, basically right before he hits the boat, and then right after he hits the boat. So you don't have to worry about him jumping off of the dock or anything like that. That's something that we'd look at with momentum impulse, which is other things to come. All right. We're looking at a perfectly inelastic collision. We start off with two objects, the fisherman and the boat. So I'm going to say that the mass of the fisherman, and the initial velocity of the fisherman, plus, I don't want to do all of this in beige, so mass of the boat times the initial velocity of the boat. And each of these need vectors, as we've talked about before. Well, the mass of the fisherman is, for me, 82 kilograms. And the initial velocity of the fisherman is 3.4 meters per second to the west. They told us that east is the positive direction. The way we normally draw it is to the right. That means west is going to be to the left. And west, by definition from that note, is the negative direction. So negative 3.4 meters per second. Plus the mass of the boat, which is 124 kilograms, times 0 meters per second because the boat is not moving initially. This is going to look a lot like the car crash ones that we looked at in class. I'm going to take 82 kilograms times negative 3.4. I'm going to end up with my initial total momentum for my system is 278.8 kilogram meter per second. That is my total momentum for the fisherman boat system. And we're going to assume that there are no significant external forces. Basically, let's say that the boat is pretty easy, free to slide to the side. That may not be a very good assumption, but for our purposes, we'll go ahead and do that. It'll get us a pretty good ballpark for exactly how fast the boat's going to go. In the end, we have one object. When the fisherman and the boat stick together, they're going to move together. And so we're going to need 82 kilograms plus 124 kilograms times our final velocity of the both of them together. So that's going to be what, 204? If I'm not mistaken, 204 kilograms times V final. And we're going to set that, that's what I end with, 204, oops, 204. Oh, no, 206. 206. 2 and 4 is 6. 206 kilograms times V final. I can feel people commenting already. All right, just to be safe, because I've already messed this up once, 82 plus 124. Yay, 206. I can math. I'm going to divide both sides by 206 kilograms. And that's going to leave me with the following. So 278.8 divided by 206 gives me my final velocity of fisherman and boat together is 1.35 meters per second. It's actually 1.3533, etc., etc. But that's to that. To three significant figures is 1.35. Let me find my answer key here. Where's that at? That's not that one. There we go. Oh, I'm sorry. Look at me. Negative. I am making mistakes all over the place. I should probably go home and get some sleep. Negative, because it's to the west, negative 1.35 meters per second. I apologize. That's what you're going to need to put in because they have told us the east is the positive direction. The fishermen in the boat are moving 1.35 meters per second to the west, so that negative very much needs to be there. My apologies.